All right, welcome back from your lunch, and thank you for introduction. And actually, the name is not Hivemall, it's not mailer, Hivemall it is. So this is Takuya Kitazawa, and today I'm going to introduce about our new machine learning library, which is developed under Apache Software Foundation named Apache Hivemall. This is actually introduces a new paradigm named query-based machine learning. So I'm going to talk about the topic throughout this session. So like I mentioned, I will talk about machine learning in query language. Can you imagine what's going to happen there? Probably many of you are doing machine learning by writing Python code or sometimes R or Julia, whatever you want. But I guess nobody has ever tried machine learning in query language. So I can show you some examples. But first of all, I want to introduce one news came from Google I/O 2018. Google has recently been introduced their new functionality on their Google BigQuery platform named BigQuery ML. Is there anybody who already know about it? All right, no one. Google BigQuery is a data warehousing solution on top of the Google computing platform. And BigQuery ML allows you to execute machine learning operation for the data stored in BigQuery data warehouse by writing SQL. So that's the thing that Google has recently been introduced. And I can easily imagine the motivation behind the solution. So let's imagine the scenario. Your customer asked you to develop some prediction model, regression model of massive data stored in your data warehouse. So how can you implement the solution on top of that question? There are some considerations we have to do here. First of all, in order to implement the regression model, we have to understand some sort of theories behind the machine learning. And also, we have to handle massive data. It means the solution has to be scalable. Another part is the data warehouse. How to access the data stored in data warehouse. There's the Python interface in it, or is there any other options about it? We have to think about a lot of things related to that. Plus, it is obvious that we do have to have some practical experience in terms of both theory and the practice of machine learning. So what I want to say here is machine learning, real-world machine learning is not super easy. There are a lot of things we have to know and we have to experience before tackle your real-world problem. So thanks to the machine learning solution, BigQuery ML, or query-based machine learning paradigm, even though you don't have any expertise in machine learning, you can take advantage of your machine learning algorithms on your huge amount of data in a scalable manner by just writing some 10 lines of queries. That's it. You can apply machine learning to your data easily. So basic motivation is machine learning for everyone. Everyone who don't have any expertise in machine learning or mathematics, people can enjoy machine learning on your data. And in terms of for everyone's part, the solution has to be open source. So here's the open source solution for the query-based machine learning paradigm named Apache Hivemall. And there's a GitHub repo here, probably you can see it, github.com, Apache Incubator Hivemall. So let's go to the URL. You can check out some documentation or examples or tutorial, or even you can contribute to the package as you want. But I'm going to introduce about the package throughout this session. But first of all, so I will try to show some more concrete examples in terms of queries, so concrete queries to you guys as much as I can. But before jumping into that part, I will talk a little bit more about the theoretical or conceptual part of the query-based machine learning. So how Hivemall or query-based machine learning in general works in real-world machine learning workflow. So why Hivemall is preferable and who can get the advantage of that. So this is the real of the machine learning workflow. Generally, we start from the problem and we need to build some assumption or hypothesis based on that problem. And we do have some data related to the problem, or probably we need to prepare some data collection step before starting machine learning stuff. But anyway, we have data, and based on the assumption and the data, we need to apply some pre-processing to it before starting machine learning. And eventually, you can build your machine learning model by using some tools like Python or TensorFlow or Scikit-learn. Probably it's Mahout or something like that. And after that, you need to evaluate the accuracy of prediction. And if it's satisfied, the model is ready for production. So after that, it's going to be more like an engineering matter. But if it's not, the accuracy is not satisfied for you, you have to go back to the assumption and tweak your model. But anyway, there are a lot of tools and a lot of theories we have to understand to run real-world machine learning workflow. So some non-experts like business analysts or any other your team members which are not coming from engineering or scientific department has to be, it's not impossible to work on this workflow. But I have a question here. Do you really need such complex or flexible solution, machine learning solution, to all of your problem? Is it true? I don't think so. Based on my practical experience in the B2B industry, in my experience, many of real-world business problems can be solvable by using some simple techniques and simple tools. So let's imagine the scenario, okay, this company wants to predict customers' churn to prevent their churn in the future. That can be solvable by just writing, logistic regression. You don't necessarily have to implement complex deep learning stuff. And how to implement the logistic regression? Okay, if you understand Python code, you can use scikit-learn. But the situation can be more simpler by using query-based machine learning. In terms of the simplicity of algorithm, there are some examples here. So this is an example from the Google BigQuery ML. Their documentation says, all right, BigQuery ML currently supports linear regression and binary logistic regression and multi-class logistic regression. That's it. There's no deep learning stuff here. The another example here is coming from Amazon machine learning. Not deep learning stuff, Amazon machine learning, simple machine learning solution. And they says, okay, Amazon ML uses binary classification based on logistic loss, multi-class classification based on multinomial logistic regression, or regression based on squared loss function. That's it. So it's simple, but it works on your real-world problem. So if you replace your machine learning workflow with much more simpler query-based paradigm or solution, the workflow will be more and more simpler and easy to understand even for non-experts like business analysts or probably your executives in your company. I don't know. But the only thing you to know is SQL basics. If you understand SQL, all right, it's ready to execute machine learning. That's the thing the query-based machine learning provides to you. But I have to mention a little bit about the flip side of here. Writing machine learning by SQL means we have to write many tiny query fragments in each single step in the machine learning workflow. So let's see the example of the pre-processing. We have to write single query for data extraction, and another query comes into later for data filtering. And the third one will be probably for interpolation, and the next one is for normalization or something like that. So we will be suffered from the many tiny query fragments. How can we organize the query fragments? Yeah, there are many ways to handle the issue. And I would suggest to combine the query-based machine learning paradigm with workflow engine, whatever you want. For example, from the Apache project, there's a project, workflow engine named Apache Airflow. Or probably another solution like Luigi, you can use that. But here, for the diversity perspective, I show another workflow engine as an example, named DigDag. DigDag is also a distributed workflow engine. And DigDag allows you to write many complicated or highly dependent your workflow by just writing some YAML file. All right. in the YAML file, you have to define, all right, this is the pre-processing task. And inside of the pre-processing task, there are multiple different parts for normalization, filtering, extraction, something like that. And probably you can execute some part of that in parallel. You can define this kind of workflow by just writing a simple YAML file. That's the thing the workflow engine provides you. So the combination between workflow engine and the query-based machine learning is the best from my perspective. So that's pretty much everything about what I want to tell you throughout this session. So let's summarize what I said. First of all, there is a new paradigm named query-based machine learning. Machine learning can be implemented by just writing SQL or queries. This is a new option outside of the classical common machine learning toolkit, mainly coming from Python or something like that. And I don't want to force to you, okay, let's replace your machine learning solution completely with Hivemall or something like that. I don't want to say that. But please keep in your mind there's a new option here, and it's much more simpler compared to the classical paradigm. So there is a trade-off between that for sure. But I want to introduce this new paradigm. And this can be much more simpler in terms of machine learning or implementation or scalability. And the OSS solution for the query-based machine learning named Apache Hivemall and workflow engine. That's the combination. All right, so from here, we're gonna dive deep into the detail of or actual usage of Hivemall, how Hivemall works, and how you can use that. First of all, I have to mention about Apache Hive for sure. So is there anybody who already know or already use Apache Hive? Okay, 1, 2, 3. All right, I can see many. That's surprising. All right. Apache Hive is a data warehousing solution built on top of Apache Hadoop ecosystem. And you can efficiently access or analyze massive data stored in your data warehouse by just writing specific query language named HiveQL. So you can basically do pretty much the same thing compared to the standard SQL syntax. Like you can do query table, create table, or select, join, grouping by, or order by. And also notable thing here is the cluster by, because Hive is for more like distributed fashion. So cluster by operation enables you to more efficiently access your data over the multiple nodes or your Hadoop clusters. And as the name suggests, Hivemall is an extension of Hive query. So this project is currently under the Apache Software Foundation project and incubator project since 2017. So we are currently actively developing this library for the graduation from the incubating project as a matured to Apache project. But anyway, this is the open source. And this is scalable machine learning built as a Hive user-defined functions, UDF. So the good thing in Hive here is you can write any of you want. You can write custom function, query function by writing some Java code for Hive. So Hivemall stands on that functionality from Hive. And Hive's user-defined function, there are 3 different types of user-defined functions here. One is UDF. This is a simple user-defined function. In the context of machine learning, it's mainly used for pre-processing. Right? Okay, Hivemall actually has a function named L1 normalize. This applies L1 normalization on some array or feature vector. And it gives you the one-to-one transformation to the original table. So this is the UDF. Another one is UDAF. A here means aggregation. It's more like sum or average or max operation in the standard SQL. And in case of machine learning, mainly it corresponds to some, for example, evaluation metric. Hivemall supports many evaluation metric, and one of them is, of course, RMSE. All right, let's imagine the example. All right, there's a table there are 2 columns here, and 1 column is for the ground truth, and another column is for the predicted value. By aggregating all rows in the table, with evaluation metric function like RMSE, finally generate a scalar value, single value as an output, or RMSE on that table will be 0.98 or something like that. This is the basic behavior of the aggregation function. And the third one is the TUDTF. T here means tabular. It means the function generates completely new table from the input table. It clearly corresponds to training function in the context of machine learning and Hivemall. So once you input your data to the Hivemall function, for example, there is a function named train regressor. Once you pass your data into that function, finally, new table which represents machine learning model, or actually parameters learned from the data, will be populated as a result of this function. So there are three types of user-defined function, and Hivemall effectively uses all of them, and each of them plays a really important part in the context of machine learning workflow that I showed before. And there are 4 different characteristics I want to emphasize here in the Hivemall. One is, of course, it's easy to use because it's just SQL. You don't necessarily have to write Python, or you don't need to care about how to write programming or how to run programming. And it's scalable. It stands on Hadoop ecosystem. So it's originally designed for distributed, scalable parallel processing. So it automatically runs in parallel in the environment. And also it's versatile. The example I showed before, BigQuery ML, that's the one example of the query-based machine learning, and they support 3 algorithms. Hivemall, of course, supports those 3 algorithms, but in addition to that, we do have any other options. For example, like I showed before, there's multiple evaluation metrics in Hivemall, or you can do some feature engineering by just using Hivemall. So Hivemall can do pretty much everything in the machine learning workflow. And fourth point is the multi-platform. Like I said, Hivemall stands on Hadoop ecosystem. And the ecosystem contains a lot of options. There are some flexibilities in the selection of each data processing layer. So you can probably choose Spark to take advantage of Hivemall's efficiency or functionality. Or you can, of course, use Apache Pig to use Hivemall. It is, of course, possible. So from here, I'm going to show the detail of these characteristics one by one. First of all, Hivemall is easy to use and scalable. So this is, all right, welcome. So here's the first query example from the Hivemall. So in the context of scalable machine learning in the Apache project, there was an option from Apache Mahout. In Mahout, you have to write like this kind of Java code to implement scalable logistic regression. But what about Hivemall? The only thing you have to write is this 10 lines of query. And let's see, does it work? Oops, it doesn't work. All right. All right, let's see the query one by one. And most nested part, select features and label, is coming from training table. So I will explain more about it later, but the training sample takes here, and here's a cluster by operation. It means I want to randomly shuffle all training samples as the first step of training. This is very important for stochastic gradient descent, as you already know. And the second nested part, we call a function named logless. It means I want to train logistic regression model. For the input data already shuffled before, input data, features, and label. And as a result of training, brand new table will be populated. And this table has 2 columns. One is feature, and another one is weight. Because you already know logistic regression is just a simple linear model. So as a model parameter, the only thing we have to hold is the model weight, or feature weight for each feature. And the important thing here is we have to finally group by over each feature and take average of weight, because the operation will be executed in the distributed manner. So probably the output will have some multiple result for single feature. It's gonna be happen. So in order to prevent some bad result, we have to group by feature and take weight to finalize the training. This is the basic example of how Hivemall works, or how query-based machine learning works. And of course, this will be executed in the Hadoop ecosystem, so it automatically runs in parallel. All right, let's dive into the detail of this query. So in terms of feature representation, Hivemall supports space-efficient feature representation, which means you can take advantage of sparsity of the input vector. Like, I guess you already know about the feature representation named libsbm format. Open source library libsbm has some specific representation of the input data named libsbm, which is very useful to represent your feature, in a sparse feature vector. So Hivemall basically follows that representation, but there are some extensions in it. But basically, it follows libsbm format. So feature is represented as just a single index or feature name, or sometimes the concatenation of feature name and its value. Every single feature is represented as this format. And feature vector here is just array of features in Hive. And there are two functions you can use to build your feature vector on Hive. One is quantitative features, which convert the input representing quantitative feature to a feature vector for quantitative features. So this example says, all right, first argument says the feature names I want to convert. So I want to convert two features. One is named price, and the second one is named size. And following argument corresponds to each of the feature name. So the second argument corresponds to first feature name, price. And third argument corresponds to the second feature name, size. All right, feature name list is here, price and size, and price is 600, size is 2.5. Eventually, what Hivemall generates is an array of strings here. So price 600 and size is 2.5. Or if it's categorical, the usage is pretty much the same. But difference here is missing values is automatically ignored here. So if you want to interpolate some missing data, you have to do that before that. But anyway, null is automatically ignored. And for categorical features, Hivemall internally automatically does one-hot encoding based on the input. So let's see, this example says first feature is gender and value is male. So in this case, gender sharp male represents male value for a categorical feature named gender. So if another record says gender sharp female, in that case, Hivemall automatically converts this feature named gender into one hot encoded representation as a table. Or for preprocessing, Hivemall supports feature hashing. Feature hashing is very useful to approximate your high-dimensional data and to take advantage of some scalability on it. So you can do feature hashing to the input feature vector created like before. So let's see more concrete example here. Imagine you have a table named purchase history. So each record represents if this situation leads purchase or not. So there's 4 features here: day of week, and customer's gender, and product price, and its category. And the final column, label, says if this situation is purchase or not. Let's imagine the situation. So feature engineering can be done like that. So select from purchase history. We are focusing on purchase history table. And here we are calling two functions that I explained before, quantitative features and categorical features. So for quantitative features, we have price. So feature name is only one, it's price. And second argument is the name of column. So we want to use price column for a feature named price. Categorical features are the same. All right, so there are three features: day of week, gender, and category. This is the feature name. And following arguments represent the name of a column. So we are focusing on day underscore of underscore week. This is the column name, or gender or category. So here, this query separately creates feature vector for quantitative features and feature vector for categorical features. So what we finally need to do is to concatenate those guys as a single array, single feature vector. So this is another Hivemall function named array concat, which simply enables you to concatenate 2 or 3 more arrays into a single one. Eventually, what you can see here is this table. I will call this table as training because I want to use this table for training later. But don't forget about ID, it's just auxiliary one. But there are two columns, features and label, like I created before. And features is an array of strings, feature vector here. And label is just simply taken from the original table because I want to train. I want to do supervised learning on that data. Or there are some options. You can put new function on top of the previous query named add bias. You can put the bias term to your model if you want. It generally improves your prediction or accuracy for unforcing data. Or, like I explained before, you can apply feature hashing to the feature vector created before. Anyway, you can create a feature vector, pairs of feature vector and your objective target value by using some Hivemall functions. This is the feature engineering part you can implement by using Hivemall. So it's time to do supervised learning for that data. So this is a very simple example to train linear classifier. So select from training. Training table corresponds to the previous one I showed. And we are calling train classifier. This trains classification model, which is actually corresponding to linear models. Or if you want to solve regression problem, there's an alternative option named train regressor, but I will focus on classification here. And first argument is features, feature vector. And second argument is label, so your objective. And third argument is for options, because in reality, some hyperparameter optimization will be important to achieve the best accuracy. So first option will be loss function. For classification, there are some options as a loss function: hinge loss, logistic loss, squared hinge loss, or modified Huber loss. For regression, also there are some options: squared loss, quantile, epsilon insensitive, squared Huber loss, or something like that. And following parameters says you can choose optimization scheme. We do have SGD option, but if you want, you can use add a grad or add a delta or atom. Or for the regularization, you can choose one of L1 regularization, L2 regularization, or elastic net, or RDA. Or some more advanced option, you can adaptively control learning rate over the iteration for stochastic gradient descent training. Or you can do mini batch training if you want. Or some early stopping option exists in order to finish your training as soon as possible. The loss is converged. But anyway, important thing is the first two arguments, and the third one is optional. So Hivemall we try to implement this function works effectively on a variety of data with default parameters as much as possible. So you can try train classifier function without options at the first step. And if you are not satisfied with the result, okay, let's take a look at the detail of the parameters, and probably we need to tune the parameters to achieve the better accuracy. So, as a result of training, output will be, okay, let's see this as part called train classifier, and output as feature and weight. Like I explained, linear model will be represented as a pair of feature and its weight. So output is going to be a table here. So feature and column, there are two columns. And for example, for a feature named day of week Wednesday, weight is going to be 0.74, something like that. And this weight part, of course, corresponds to the W in the representation of the linear model. In terms of regression or classification, there are more options inside of Hivemall, so you can choose anything you want. But notable things are here is factorization machines and random forest. There are more well-known and easy to use or effectively runs options. Factorization machines is originally coming from the field of recommender assistance, but it looks like this one. So it looks like more like polynomial model, but it's slightly different. Anyway, a prediction on the factorization machines is represented like this one. All right, so you can train a factorization machine by using Hivemall. The function name is actually train FM regressor or classifier. As a result of training, can you imagine what kind of table will be populated? So in case of its linear model, the table looks like that. So what about this kind of model? Output is going to be like that. So first column is for the global bias. And following part is corresponding to every single feature. And the first column is for linear term. And third column is for more complicated polynomial term, actually named interaction term, which is represented as an array of some many parameters. So it's a little bit hard to understand, but we need to convert machine learning model into some sort of table in order to execute machine learning operation on top of Hive and Apache Hadoop. So Hivemall stores machine learning model in that format. So what about random forest? You can build random forest model by using train random forest classifier. And parameters are pretty much same as the linear model. So this simplicity is really important and a good thing for the query-based machine learning paradigm. But third argument, options are more different. Of course, it's a different model. But usage is basically same, but outputs are different here. It's not simple feature and weight. There are more columns will be populated. Model ID, model weight, something like that. Can you imagine what kind of data is stored in the resulting table? The real is here. So we have to somehow convert decision tree into a single cell in the table in order to store the machine learning model or random forest model into Hive. So Hivemall is currently trying to encode original decision tree into a string format, text format here. And prediction can be executed like that. So there's another function for tree predict. By using this function, Hivemall internally automatically decode the encoded model into original decision tree, and it can make prediction on your input data. And finally, as many of you already know, random forest is ensemble technique. So we have to ensemble all prediction results created by every single decision tree. So we have another function named RF ensemble. Of course, visualization is important and very useful, especially for random forest. So we have interesting function here, tree export. By passing the encoded model to that function, you can get more human readable model representation. And there are some options. And type is JavaScript. It means decision tree is converted to if-else statement. So you can immediately deploy your decision tree into your web application. I don't know if it's useful or not, but it's more human readable. Or another option is GraphViz. So you can visualize your decision tree like that. And you can immediately use this figure in your research paper, probably. So that's the basic usage of Hivemall in terms of regression and classification. I don't know if you feel comfortable on this kind of implementation of machine learning. But from business analyst or non-expert perspective, I believe this kind of paradigm makes machine learning much more simpler. So another characteristics here is versatile. So like I explained before, you can use Hivemall for more than machine learning stuff. You can do feature engineering or evaluation by using Hivemall. So there are some options. For feature engineering, Hivemall can do feature hashing, scaling, binning, or TF-ID effectorizer, something like that. Or evaluation metric, Hivemall supports many metrics, including AUC, NDCZ, log loss, precision, recall. Or not only about machine learning, but also some generic functions are supported in Hivemall. So some basic array or map-related functions are implemented in Hivemall. It's pretty much useful, mainly for preprocessing of data. Or bit or compression of operations can be implemented by using Hivemall function. And notable thing here is efficient top K query processing. Imagine this kind of scenario. Okay, we have a table here, item, user, and score. So let's list top 3 or top 2 item, top 3 here. But actually query says 2, so it has to be 2. List top 2 items per user by writing query on that table. It's gonna be complicated, but if you are familiar with SQL, you can probably write the query looks like the above one. So you can implement it, the solution. But unfortunately, it's not scalable and it's not efficient. It actually takes more than a day for 20 million users and 1K items for each user. Such kind of massive data, the above query takes probably more than a day. So Hivemall is some specific function named each top K, which do exactly the same thing that the above query does, but this is more efficient. Because internally, the Java implementation holds some bounded priority queue. So Hivemall efficiently process incoming record and efficiently obtain top n items per some specific key. Key means here is user. So the importance of this operation is mainly in recommendation. Recommendation is actually one of the most important applications you can implement it by using Hivemall. So, of course, machine learning or data science application is mainly based on historical data. And historical data is generally stored as a tabular form in your data warehouse, or maybe in MySQL. But anyway, recommendation stands on historical data. Historical data generally stands on tabular format, tables. So the interesting thing here is Hivemall enables you to apply machine learning or some specific functions seamlessly to your tables. That means recommendation in Hivemall is very seamless and simple and easy to implement it. So actually, there are some options you can do in terms of recommendation. So there are some k-nearest neighbor optimization here, options here, or some efficient item-based collaborative filtering is available in Hivemall. Or of course, you can enjoy some classical but very powerful matrix factorization or factorization machine techniques can be used to build your recommendation engine. But anyway, Hivemall and recommendation and tables is the combination. And so that's the reason why recommendation is one of the most important applications for Hivemall. And recommendation is mainly for taking top K. So making prediction for every possible pairs of users and items. And let's take top 5 or 3 items for each user and show that result on the UI. That's a thing way actually Amazon or something like e-commerce site does. Additionally, there are some more applications here. So Hivemall can do natural language processing or data sketching, which means more, you can approximately compute your massive data by using this sketching technique, or geospatial functions available. So if your data has some sort of, latitude and longitude, you can convert the tables into some different types of format. Or anomaly detection or change point detection is available in Hivemall. Or topic modeling, you can do that by using Hivemall. So everything is documented in the Hivemall documentations, and I will provide some link after the session, but you can do pretty much everything about it by just writing SQL. The final characteristic here is multi-platform. Like I said at the beginning, inside of the Hadoop ecosystem, there is a flexibility for the selection of each layer. So in order to process your data in parallel, there are some options. You can choose, of course, you can use standard classical MapReduce framework to handle that. But also, you can use Apache Tez or Apache Spark to more efficiently and effectively analyze or process your data. So there's some flexibility to the choice of here. And on top of the data processing layer, interface. It's flexible. Of course, you can use Hive like I showed before, but you can also use Apache Pig or Apache Spark. So here's the Hive query to train logistic regression. This is the same as the first one. What about Pig? Pig can be like that. I'm not super familiar with Apache Pig, but you can write the very same operation on Apache Pig by using Hivemall like this way. Or if it's Apache Spark, you can apply Hivemall function to Spark data frame. Or if you are more comfortable with just query representation, you can use Hive context, which is available in Spark. You can directly call your Hivemall functions by writing same SQL. Or it's still under consideration, but we strongly want to apply Hivemall capability to the real-time data processing or real-time prediction. So we are thinking to combine Hivemall capability to Spark streaming. Looks like this one. There are many future plans in Hivemall. For example, Hivemall is planning to support Word2Vec, which is already actually implemented, but it's not stable here. So I want to try to implement it, improve that. Or advanced version of factorization machine method is also developed, and also try to improve the stability. Or XGBoost, gradient boosting, like GPM, will be supported inside of Hivemall. So this is the example of XGBoost with Hivemall. It's just still experimental, but usage is pretty much same as the linear model. So parameters or arguments are only two. One is for features, another one is for label. It's same. But internally, Hivemall behaves very differently. Anyway, you can install Hivemall just 2 steps. The only thing you have to get is to download 2 files from our repository. One is compiled jar file, and another one is definition file, which defines Hivemall functions and tells the Hive, all right, this is our custom functions. You have to enable these functions on your console. And once you enter your Hive console, you have to call 2 operations. One is add jar, and call that jar file. And the second one is source definition file here. That's it. You can take advantage of Apache Hivemall or query-based machine learning or newer data warehouse. So, does it work? Yeah. So I have previously uploaded some demo video on YouTube. So I don't want to show everything to you guys here, but you can search Hivemall recommendation on YouTube if you are interested in that. So for example, you can use Amazon EML to execute Hivemall Elastic MapReduce, which automatically already bundles some Hadoop environment in it. So the only thing you have to do is to just download the 2 files and call the Hive console here and just launch 2 operations that I introduced before. That's the installation of Hivemall. All right, that's it. So don't forget about the repository and put the star in it. So github.com and Apache Incubator Hivemall. And I'm really welcome to your contribution to that repository. And also we have some Docker image or documentation or step-by-step tutorial in it. And unfortunately, Docker image is not fully scalable, but it's a very good starting point to play with the query-based machine learning. So making machine learning is more easy, more scalable, and clean, and shareable by implementing your machine learning solution in query language with Hivemall. That's the thing I want to show you in this session. Thank you.